Okay, so now I'm going to go ahead and work a problem where we're actually going to solve a rational function. So instead of just doing what we've been doing, we're adding, subtracting, multiplying, dividing, and simplifying, we're actually now going to solve it. So we're going to solve for x. I have a fairly straightforward problem here, which is 2 divided by x minus 2 equals 3 over x plus 5 plus 10 over x squared plus 3x minus 10. So the first thing I'm going to do is I'm going to go ahead and make sure anything that factors, I'm going to factor it to make my life easier. And then from there, I'm going to look and I'm going to find what my domain can't be. I'm going to find my domain restrictions. So in event that at the end of the problem, if I get one of my answers is in my domain restriction, it won't actually be an answer. It'll be an extraneous solution. All right, so let's see. Right off the bat, I see that I have 2 over x minus 2. This is already fully factored. This is going to equal 3 over my x plus 5. That is fully factored. And then plus, I've got a 10, but my bottom here is not factored. Well, this does factor nicely to a x minus 2 and x plus 5. Okay. So now here I could go through and I could add everything up. I can add these, cross multiply and everything else. What I like to do is actually call a technique called strike the denominator. So I'm actually going to make all my denominators the same, and then I'm just going to set the tops equal to each other and solve that way. It makes life so much easier. But the first thing I need to really look at is my domain here. So x cannot be 2 or negative 5, 2 or negative 5. So I know that x cannot equal 2 or negative 5. So in the event at the end of this problem, if I get an answer that is 2 or negative 5, can't be an answer. It would be an extraneous solution. So let's see what we've got to do to actually get rid of this denominator. All right, so I'm going to look at this fraction right here. I have 2 over x minus 2, and I'm going to look at all my denominators and say, what is this fraction missing? What's missing? The x plus 5. So I can actually do is just multiply this whole thing by x plus 5. So I'm going to have 2 times x plus 5 over x minus 2 and then x plus 5. So here's the x plus 5 that I added in there. This is going to equal, so I'm going to look here, the x minus 5. What is it missing out of all these? What's missing? The x minus 2. So I'm going to do 3 x minus 2 over x minus 2 x plus 5. Then, of course, this is still plus 10 over x minus 2, x plus 5. Okay, now that I have this, now that my denominators are all the same, all I simply have to do is just solve the tops. The only way that this can be true is if I have 2 times x plus 5 equals 3 times x minus 2 plus 10. So I just take my numerator, set them equal to each other once I get all my denominators match, and I'm going to solve. So now I'm going to have 2x plus 10 equals 3x minus 6 plus 10. 2x plus 10 equals my 3x plus 4. I'm going to move my 2, subtract my 2x, so I'm going to get 10 equals x plus 4, subtract 4, and I'm going to get x equals 6. And there's my answer. Now I'm going to look here, x equals 6. I'm supposed to technically plug it back in here and make sure I don't get 0 in the denominator, but because I already looked here, I know that 6 doesn't match one of the numbers it cannot be, so x is my actual solution to this problem. Not terribly bad to solve.